Hey everyone, and welcome back. Ready for another deep dive?
I'm ready.
All right, well, buckle up because today we're diving into something pretty fascinating. It's a phenomenon that's changing the way we understand climate change.
Oh.
Yeah. We're heading up north to the icy landscapes of Greenland
Right.
to investigate a surprising link between, get this, microscopic algae, a vital nutrient they can actually store, and the accelerating melt of glaciers.
Oh.
I know, right?
Algae and glaciers. That's an interesting combo.
It is, and to help us unravel this mystery, our main source today is an article from Aarhus University. It's titled, "Scientists Just Uncovered a Hidden Force Behind Faster Ice Melt."
Sounds intriguing.
And let me tell you, this hidden force, it's incredibly small. We're talking microscopic, but it packs a powerful punch.
I'm starting to see why we're doing a deep dive on this.
Yeah.
It's amazing how something we can barely see can influence something as massive as the Greenland ice sheet and, by extension, global sea levels.
Right. It's almost like a David and Goliath story, except in this case, David is a tiny little algae.
Tiny but mighty.
Exactly. So to kind of set the scene, imagine those stunning pictures of glaciers, those vast expanses of white ice stretching as far as the eye can see.
Yeah, I've seen those pictures.
Now picture those glaciers starting to melt as spring arrives.
Okay.
It's kind of like how flowers bloom on land as temperatures warm up, right?
Right.
Well, something similar happens on the ice. Algae, which are naturally present on the ice sheet, start to, bloom.
So they're like ice flowers.
You could say that. And they create these vast, dark patches that change the color of the ice.
And that color change, that's critical because it impacts how much sunlight the ice sheet reflects, right? Instead of the sunlight bouncing harmlessly back into space, it gets absorbed by the darker ice, leading to faster melting.
Exactly. Okay, so far so good, right? Scientists have known about this algae-driven darkening effect for a while. But here's where the puzzle gets interesting.
Okay, I'm listening.
They always assumed that the spread of these algae was limited by the scarcity of nutrients on the ice.
Yeah, that makes sense.
It was kind of seen as a frozen desert,
Right.
lacking the essential ingredients for life to really thrive. But this new research challenges that very assumption.
Oh.
What they found is that ice algae have developed this incredible survival strategy. They can actually store a vital nutrient called phosphorus.
Whoa, hold on.
Yeah.
They can store phosphorus.
Allowing them to flourish even in environments where it's in short supply.
So they're not as restricted by low nutrient conditions as we previously thought. It's almost as if they found a way to create their own little oases in this icy desert.
It's mind-blowing, isn't it? These algae are basically like tiny little preppers stocking up on essential supplies to survive in a harsh environment.
That completely changes our understanding of their potential to spread, doesn't it?
Absolutely. And this is where our star researcher enters the picture, Laura Halbach, a PhD from Aarhus University. She's the one who cracked this case wide open.
Impressive.
Now, I know we don't want to get too bogged down in scientific jargon.
Yeah, keep it simple.
But I'm genuinely curious, how did she actually figure this out?
Right. It's not like you can just ask the algae what they're eating.
Exactly.
Well, Halbach and her team, they developed this incredibly innovative technique.
Okay.
It's called isotopic tracing.
Isotopic tracing.
Yeah, it's not just about tagging nutrients. It's about using different forms of the same element, like phosphorus in this case.
Okay.
These different forms, called isotopes, are absorbed differently by the algae, allowing researchers to track their journey within the algae cells.
Interesting.
It's like giving them a specially prepared meal,
Oh, I see.
where the phosphorus is subtly labeled, allowing us to follow its path.
So it's like a... Sure.
Let's take a step back and make sure we're all on the same page about what these ice algae actually are.
Good point. It's easy to forget that we're talking about organisms that are, invisible to the naked eye.
Right.
Ice algae are single-celled organisms found on ice sheets all over the world, from Greenland to the Alps, the Himalayas, and even Alaska.
Wow, they really get around.
They do. They're like the plant world's minimalist architects.
Okay.
Incredibly efficient at harnessing energy from sunlight through photosynthesis.
Right, so they're basically tiny little oxygen factories operating in some of the most extreme conditions on Earth.
Exactly.
And they need just a few basic things to survive: sunlight, water, carbon dioxide, and trace amounts of nutrients like phosphorus, nitrogen, and carbon.
Yep, the essentials.
And as we've just learned, they're much better at finding and storing those nutrients than we initially thought.
Especially that phosphorus. Remember how we talked about the ice sheet being seen as a frozen desert? Well, thanks to research like Halbach's, we now know that it's actually teeming with microbial life. Teeming with life! So it's not a desert after all.
Not at all. It's a whole ecosystem, a hidden world of bacteria, fungi, viruses, all interacting with the algae in incredibly complex ways.
It makes you wonder what other secrets are hidden beneath the surface of these, seemingly barren landscapes, right?
Absolutely. It really highlights just how much we still have to learn about these environments and the intricate web of life that exists within them.
Yeah, it really flips the script on, how we think about these icy ecosystems.
Right.
Like, we used to believe that nutrient scarcity was the main thing holding back algae growth. But now we see that these tiny organisms have this remarkable adaptation that allows them to thrive even when phosphorus is limited.
So we've got these algae happily soaking up and storing phosphorus.
Right.
And at the same time, we've got climate change causing earlier spring melts, right? Which means more exposed ice for these algae to colonize.
More real estate for the algae. It's like setting the stage for a massive algal bloom.
Exactly. It creates a sort of feedback loop. Like warmer temps lead to more melting, which exposes more bare ice. This newly exposed ice becomes like prime real estate for the algae.
Right.
Which then darken the surface, absorb more sunlight, and accelerate the melt even further.
Oh, wow.
It's a cycle that has scientists concerned about the rate of ice loss in places like Greenland.
Okay, I have to admit, I'm starting to see why this seemingly small detail about phosphorus storage is causing such a stir in the scientific community.
Right.
It has this ripple effect that extends far beyond these microscopic algae.
Absolutely, and this is precisely why Halbach's research is so crucial. By shedding light on this hidden mechanism, she's providing valuable data that can be used to refine climate models, and improve our predictions about the future of these ice sheets.
Because let's face it, current models often struggle to account for the complexity of these microbial ecosystems, right? It's like trying to predict the weather without considering the wind.
That's a great analogy. And just like understanding wind patterns is essential for accurate weather forecasting, understanding the role of microbial life is crucial for accurately predicting the fate of these ice sheets.
Right.
Halbach's work is helping us fill in some of those critical gaps in our knowledge.
But while Halbach's findings are undeniably groundbreaking, are there any, alternative viewpoints within the scientific community? Are all scientists completely on board with the idea that phosphorus is the key driver of algae growth on the ice sheets?
That's a great question, and it highlights the importance of scientific debate and critical thinking. While Halbach's research has provided, compelling evidence for the role of phosphorus, some scientists argue that it might not be the only limiting factor. They point to other factors, such as the availability of iron, or the impact of grazing by tiny animals called zooplankton, which could also influence algae populations.
So it's not a simple case-closed situation.
Right.
There's still a lot of ongoing research and discussion within the scientific community.
Exactly. Science is a process of constantly refining our understanding, questioning assumptions, and considering different perspectives. Halbach's work has opened up a new avenue of inquiry.
Yeah.
And it sparked a lot of exciting new research directions.
That's what I love about science.
What's that?
It's not about having all the answers. It's about embracing the unknown.
Right.
And constantly seeking a deeper understanding of how the world works.
Absolutely. And sometimes the most profound discoveries come from paying attention to the seemingly insignificant details, like the ability of a tiny algae to store a bit of phosphorus.
So if we zoom out from the microscopic world of these algae and consider the bigger picture, what does this all mean for us, the non-scientist listeners who are trying to make sense of it all?
I think it highlights a few key takeaways.
Okay, I'm listening.
First, it emphasizes the interconnectedness of natural systems.
Yeah.
What happens in the seemingly remote world of glaciers can have ripple effects that are felt globally.
Right.
Second, it underscores the importance of scientific research and the need for continued investment in understanding these complex processes. And finally, it reminds us that even the smallest players can have an outsized impact, so we should never underestimate the power of nature.
I love that idea of not underestimating the power of nature.
Yeah.
It's both humbling and awe-inspiring. It makes me wonder what other hidden forces are out there, silently shaping our world in ways we're just beginning to understand.
That's a question that scientists are constantly grappling with.
Right.
And it's a question that should inspire us all to look closer, to ask more questions, and to appreciate the incredible complexity and beauty of the natural world.
It reminds me of that famous quote by the naturalist John Muir. When we try to pick out anything by itself, we find it hitched to everything else in the universe.
Exactly. It speaks to the interconnectedness of all things and the need for a holistic understanding of our planet.
And as we delve deeper into these interconnected systems, we inevitably uncover more questions than answers.
Yeah.
But that's the beauty of science, isn't it? It's a never-ending journey of discovery.
Absolutely. And each new discovery, no matter how small or seemingly insignificant, adds to our collective knowledge and helps us navigate the challenges we face as a species.
Okay, deep divers, we've covered a lot of ground today. From the intricacies of isotopic tracing to the complex interplay between algae, phosphorus, and melting glaciers. But before we wrap up, I want to leave you with one final thought to ponder. So if something as tiny as a single-celled algae can influence the fate of, massive ice sheets, what other hidden forces are at play in our world? What seemingly insignificant factors might be shaping our climate, our ecosystems, or even our own lives in ways we haven't even begun to imagine?
It's a thought-provoking question, isn't it?
It is.
It challenges us to look beyond the obvious, to consider the interconnectedness of all things, and to recognize that even the tiniest players can have a huge influence on the, grand stage of our planet.
It reminds me of that saying, for want of a nail, the shoe was lost. For want of a shoe, the horse was lost. And for want of a horse, the rider was lost.
Oh, yeah. I've heard that one.
It highlights how seemingly small things can cascade into, much larger consequences.
Right.
And in the context of our discussion today, it makes you wonder what other microscopic factors might be influencing the rate of climate change.
Yeah, for sure.
Could there be other organisms, other biological processes that are playing a role that we haven't yet discovered?
It's definitely possible.
It's a bit humbling, isn't it?
It is.
To think that we're still just scratching the surface of understanding how our planet works.
Totally agree.
But it's also incredibly exciting.
Oh, absolutely.
There's so much more to explore, so many more mysteries to unravel.
Absolutely. And with each new discovery, we gain a deeper appreciation for the intricate web of life that, sustains us all. We start to see connections that we never noticed before.
Right.
And we begin to understand the delicate balance that keeps our planet thriving.
So what can we, as individuals, do with this knowledge? How can we take this newfound awareness of the interconnectedness of all things and translate it into action?
That's the million-dollar question.
It is.
I think the first step is, simply to stay curious.
Okay.
To keep learning and to engage in conversations like this one.
Yeah, I like that.
The more we understand these complex issues, the better equipped we'll be to make informed decisions, advocate for change, and support initiatives that are working to address climate change and protect our planet.
It's about recognizing that our actions, no matter how small they may seem, can have ripple effects that extend far beyond ourselves.
Exactly. It's about understanding that we're all part of this intricate web of life and that our choices have the power to shape the future of our planet.
Well said. This deep dive into the world of algae and ice melt has been a real eye-opener.
I agree.
It's amazing how something so small can have such a profound impact on something so vast.
It is pretty mind-blowing.
And on that note, I think it's time for us to surface from this deep dive.
Time to come up for air.
But before we go, I want to leave our listeners with one final thought.
Okay, shoot.
As we've seen today, even the tiniest organisms can play a crucial role in shaping our planet's future. So as you go about your day, take a moment to appreciate the interconnectedness of all things, the beauty of nature's complexity, and the power of scientific discovery. Keep exploring, keep questioning, and keep diving deep into the wonders of our world. Thanks for joining us.